children, I'm Professor Bert. Today we're going to look at an invisible force. It's something that we can't see but we know is there. I've got some helpers with me to assist me. First of all, we've got Teddy and we've got Benny.
Hello.
In a minute or two you're going to do a science experiment on your own. But firstly, I want you to try rubbing your hands together. What happens? Benny, rub your hands together. What happens?
My hands are getting warmer.
Exactly. That is because our invisible force is at work. The fact that you can feel your hands getting warm shows that the force is working. It is an invisible force called friction. F-R-I-C-T-I-O-N. And it is created when two objects come in contact with each other, just like when you rub your hands together or when you slide down the slide in the playground.
Oh.
Today we're going to do a friction investigation experiment. I'm going to show you how to do the experiment and then you're going to do it yourself. Teddy wants to make a new racetrack for his toy cars. He wants to make the cars run as fast as possible and wants us to test out which of these surfaces would make the best track. We have 4 pieces of track to try. The first piece is a lino track. The second piece is a sandpaper track. The third piece is a bubble wrap track. And the fourth piece is a carpet track. Once we have built our track, we will run our cars down it. The track that allows the car to run furthest will have the least friction and will be the best surface to make our racetrack out of. The first thing you have to do is get all your apparatus together. You will need a ruler, 4 different tracks, a brick, and your own car to run down the track. Finally, you should make a little table for your results. So what you do is you set your brick at one end and then place your board on top. Once you have done this, you place the car on top of the ramp and let it run down the ramp. Once it has stopped, you measure how far it ran and record your measurement in your table. Are you ready, my young apprentice? Here goes.
The measurement is 75 centimeters.
Now record it in the table and we'll move on to the next one.
Professor Bert, this time I'm going to increase the height of the ramp so the car runs faster.
No, my little helper. By doing that, you would make the test unfair, because the car would be running from a greater height than the first time. To make it a fair test, what must we do?
Make sure that everyone gets a turn.
Well, everyone will get a turn, but to make the experiment fair, we must make sure that everything is kept the same throughout the experiment.
But Professor Bert, I want to use my own car next time. It's a Mini Cooper and it's faster.
Sorry, my young helper, but for the test to be kept fair, we must use the same car every time. The tires in your car could be different to mine and cause it to run differently. Therefore, it would provide an unfair result. What we could do, if we have time at the end, is to try and run your car down all 4 ramps and compare the difference between your car and my car.
Professor, we always have to consider safety when we're doing science. Is there anything we need to consider with this experiment?
A very good point, my young helper. We should always consider safety in science. With this experiment, however, there is not too much that we have to worry about. However, be careful when moving these big bricks about. They are very heavy and they would hurt you an awful lot if one of them dropped on your little finger, so try to be careful.
So, are we ready to start the experiment?
Not quite. There is one thing left that we have to do, and that is make a prediction. Which track do you think the car will run furthest off and why?
Well, I think probably...
Wait, just keep that thought to yourself, my young helper. We'll let the girls and boys decide that for themselves. Have a discussion with your partner, and boys and girls, and come up with your answer. Which track do you think the car will run furthest off and